So continuing with our rational powers, let's go ahead and try to solve an equation that is written as a rational power to start with. So let's look at x minus 2 to the 3 halves is equal to 8. Okay, so just like before, we want to first isolate the radical. Now, sort of the radical is in disguise here, but it is the x minus 2, and it is isolated, so we are okay. So one way to think about it, I think until you get comfortable with these, it's a nice way to think. Remember that my power is power over root, okay? So in this particular case, I could also write this x minus 2 to the 3 halves as the square root of x minus 2 cubed, like this, is equal to 8. That may help us undo it a little bit easier or make a little bit more sense while we're doing it. So whenever I have something that is, I have the square root of something, to undo the square root, I end up squaring both sides. Right? When I square both sides, that undoes my radical, and I have x minus 2 quantity cubed here is equal to then 8 squared is 64. And now I have something, I'm trying to get to my x here. That's my end game, is I'm trying to isolate x. Well, x is in those parentheses, first of all, so I need to get rid of this exponent. And so to undo something that's cubed, I take the cube root of both sides. Right? And so now I just get the x minus 2, finally. And the cube root of 64, 64 is a perfect cube because 4 times 4 is 16, times another 4 is 64. So the cube root of 64 is 4. And I add 2 to both sides, and I get my 6. All right? So I do want to check my answer just to make sure, because this is a radical equation that sometimes produces answers that really aren't answers. So I'm going to plug in 6 minus 2 to the 3 halves. Does this equal 8? Right, so I end up with 6 minus 2, which is 4 to the 3 halves, is equal to 8. And yes, your calculator will do this for you if you put it in as 4 caret 3 divided by 2, like this, but it has to have parentheses. But you can do it without. Okay, so 4 to the 3 halves could be written as 4 to the, I can write it as the square root of 4 cubed. And really, it actually, with the fraction here, the order of operations works in both directions, so I could also say that it was the square root of 4 cubed. So in the first one I have the square root of 4 cubed. This one I have the square root of 4 quantity cubed. But as you'll see in a second, I get exactly the same answer, because 4 cubed here is 64, and the square root of 64 is 8, which does in fact match my answer. But just to double check, I can do it this way as well and do the square root of 4 first, which is 2, and then I end up with 2 cubed, which 2 times 2 times 2 is in fact 8. So that's kind of a nice thing when you're trying to use your numbers. I usually do the square root first just because it makes my number smaller and then square it, but it doesn't matter in which order you actually do it. And so I end up with checking out that my x equals 6 is in fact a solution to my equation. All right, so let me do one more example. I have 3x plus 2 to the 4/5 power is equal to 16. All right, so I could turn this into, it would look like the 5th root, because my root is in the bottom, of 3x plus 2 to the 4th is equal to 16. So the radical's on the outside, so the first thing that I would do is raise both sides to the 5th power, and then that would take away this, and then I would have to take the 4th root of both sides. So that is perfectly appropriate, but I would like to show a different way. I could also use this as is. Okay, so if I look at this particular thing, then that means I have this raised to the 4/5 power. So I want to get that x out of there. And so what I really want is my power to be 1 on that whole piece, the 3x plus 2. And so if I multiply 4/5 by 5/4, then my exponent would be 1. Now I can't just multiply in the 5/4, so really what I need to do is raise both sides, because that's the part where I end up multiplying my exponents. I raise both sides to the reciprocal power that I'm starting with. So my 3x plus 2 to the 4/5 equals 16. I want to raise both sides to the reciprocal power of 4/5. So I'm going to raise it to the 5/4. Now when I do that, on this side, these two things end up giving me a power of 1, which means that I just have the 3x plus 2 over here. Now, not so easy. On the other side, I end up with 16 to the 5/4. Okay. So let's simplify our 16 to the 5/4. Yes, I know you can put it in your calculator, but I just want to put some meaning behind it. So I have, let me think of it this way. I have 16 underneath here, and I have to the 5th, the 4th root of it. Now actually, I think I want to do it the other way. I'm going to do it as the 4th root of 16, and then I'm going to raise it to the 5th. You can do it in either direction. It just gives me a smaller number to start. 16 is a perfect 4th root, okay, because 2 times 2 gives you 4, times 2 is 6, or times 2 is 8, and then times another 2 is 16. So the 4th root of 16 is actually 2, and then I can raise that to the 5th. So 2 to the 4th was 16, so 2 times 16 one more time is 32. So what I really have on this right-hand side is 3x plus 2 is equal to 32. Now I just want to find my x by itself. I'm going to subtract both sides. 2, I get 3x equals 30, and I divide both sides by 3 and get x equals 10. A quick check, right, of my original equation says if I put in the 10 here, then this will be 30 plus 2, so I get 32 to the 4/5 is equal to 16. I'm checking this, so I guess I shouldn't put an equal sign immediately. I get 32 to the 4/5 equals 16, and again, I can think of this as the 5th root of 32 raised to the 4th. The 5th root of 32 is 2. I raise it to the 4th, and it does, in fact, equal 16. So this is x equals 10 is an appropriate solution. All right, that concludes our lecture on rational solving radical exponent type equations.